So radian measure is just a different way of measuring angles. Up until now, you've been using degrees, and you've been told that all the angles inside of a circle make 360 degrees in total. But 360 degrees is totally arbitrary. Somebody just made it up a long time ago. Why not 100? Why not 1,000? This way is a really convenient way of measuring angles. We define theta as the ratio of the arc length that it makes over the radius of some circle. We end up with some kind of bizarre numbers. If you remember, circumference is given by 2 pi r, 2 times pi times the radius. Rearranging, we say that the circumference divided by the radius is equal to 2 pi. So if we define this angle as the angle that you go through when you go through some arc length divided by that radius, we define 360 degrees, the full circumference of the circle, as 2 pi. So we say that 2 pi radians is equal to 360 degrees. It may be more useful if we divide both these things and get pi radians is equal to 180 degrees. This is what we have to remember. These are equivalent. Pi radians is the exact same thing as 180 degrees, or a straight line. Now, using this formula and rearranging, we find that the arc length of some segment is given by theta times r. This is really useful. If we have this angle in radians, we can quickly find the length of this given the radius. And of course, we can rearrange to find the radius given the arc length and the angle, and so on. So now we're going to have to get the hang of converting back and forth from degrees to radians and radians to degrees. So if you want to convert from degrees to radians, this is what you have to remember. This fraction equals to 1. Because these two things are equivalent, when I divide them, that equals to 1. So multiplying something by this does not change the value of it, it just changes the way it looks. Because I'm converting from degrees to radians, I want to put the unit I'm converting to on top and the unit I'm converting from down here in the denominator. Let's see an example of that. I'm going from 90 degrees to radians. So I start with 90 degrees and I multiply it by pi divided by 180 degrees. Simplifying this, remember the rules for fractions, numerator times numerator, denominator times denominator, I get this fraction. And dividing the numerator and denominator by 90 to simplify results in pi over 2. We call this exact form. We've got the pi in there. Now, of course, you could plug this in your calculator and you'll find that pi divided by 2 is about 1.57, and we call that approximate form. These are the same. We prefer this because it's exact and we haven't rounded. Now let's go the other way. If you want to convert from radians to degrees, once again we use this fraction, but now it's been flipped. Because I'm going from radians, I want that unit in the denominator, and I'm going 2 degrees, I want that unit in the numerator. So this example, pi over 6. I start with pi over 6, and I multiply it by that fraction. Multiplying numerator by numerator, denominator by denominator, I get this fraction. And lucky for us, the pi's just cancel out, and I'm left with 180 divided by 6, which just equals 30 degrees. And that makes sense. This means a sixth of pi. A sixth of 180 is 30 degrees. Finally, some common angles. It's very important to just memorize these. You don't want to convert each and every time, so it's very convenient to know that 30 degrees is pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3, and 90 degrees is pi over 2. Those will come up again and again. Our special triangles. These should look familiar. All that we've changed is, rather than this being 45 degrees and 45 degrees, we've used radians, pi over 4 and pi over 4. So this is some isosceles triangle with side lengths 1, 1, and root 2, and as a result, these two angles are both 45 degrees, or now in radians, pi over 4. And this is what we used to call the 30, 60, 90 triangle, but now we've got it in radians. Pi over 6, 30 degrees, pi over 3, 60 degrees. The side lengths are 1 and root 3 and 2. These are useful when we want to find the exact value of sine, cosine, tan of these nice angles. These are our special angles. For instance, if I want to find sine of pi over 4, rather than typing that into my calculator and getting some long decimal number, I can come on over to this triangle and find that sine of pi over 4 is opposite over hypotenuse, 1 over root 2. Cos of pi over 6, come on over to this triangle, adjacent over hypotenuse, root 3 over 2. Tan of pi over 3, there it is, opposite over adjacent, root 3. Now, not only are these three angles nice, but all of their multiples as well. Anytime we draw their multiples, we're going to end up with what's called a reference or related acute angle that is one of these angles. What that angle is a tiny acute angle relative to the x-axis that is one of those nice angles. So for example, if I want to find the exact value of sine of 7 pi over 4, well, first off, let's sketch it. If you still don't have the hang of radians, that's 315 degrees. That ends up way in here in the cosine quadrant. If you remember this from last year, you may have learned it as CAST, C-A-S-T. I remember it as all students take calculus, quadrant 1, 2, 3, 4. Because this is in the cosine quadrant, sine of 7 pi over 4 I know is going to be some negative value. Which negative value? Well, let's look at what little angle we end up with when I draw this. Relative to the x-axis here, I get pi over 4. To get around to the x-axis, I need an additional pi over 4 or 45 degrees. Putting that all together, the value of sine of 7 pi over 4 is the negative value of sine of pi over 4. Now, using our special triangles, sine of pi over 4 is 1 over root 2, and make it negative. Final answer, negative 1 over root 2. Try another one. Cosine of 4 pi over 3. 4 pi over 3 ends up in this quadrant, the tangent quadrant. So right away, because this is cosine, I know that my final answer will be negative. What's my related acute angle or little reference angle? Drawing this and counting back and finding out this angle relative to the x-axis, I find that it's pi over 3 or 60 degrees. Cosine of pi over 3, using my special triangle, is 1 over 2. But because I'm in the tangent quadrant, my final answer is simply negative 1 over 2.